yesterday we had done with the rate, what is rate of the reaction, what is molecularity of the reaction, what is order of the reaction, everything in detail we had done, and we had understood the difference between the rate and the molecularity also. Order and molecularity also. What is the difference between order and molecularity? And we had seen also one more term, that is what is a pseudo uniorder reaction or false uniorder reaction. Up to here I think we had studied. Okay, now today we are going to we are going to get the expression for K for the zero order reaction. So we are going to study the zero order reaction today. As I told that in your syllabus there are two different orders. One is zero order reaction and another one is first order reaction. So the zero order reaction we are going to study today. Okay, zero order reaction. First point about zero order reaction we are going to study is to calculate or to derive the value of K, or to derive the expression, rather you can say expression of K. Expression of K. K means rate constant, you know this. Okay, that's the first topic we are going to study. Now, under this, obviously, please understand it. This is little bit mathematical and it's not a very tough mathematics. So, you have to know this. Okay. So, zero order reaction. First of all, zero order reaction. What is order? We know order is what? Order is the power of the reactant molecules in the rate expression. In the rate expression, whatever is the power, that is the order of it. And here the power is 0, that is why the order is zero order reaction. So I am starting with a simple reaction, reactant to product. Okay, so reactant to product. If this particular reaction is zero order, can I write that minus d concentration R dt, that is rate? We know that is instantaneous rate. We are just going to do the mathematical part of it, so we are taking the instantaneous rate, the differential form. So minus d concentration R dt, that is rate of the reaction. Okay, in terms of reactant, should be equal to K, rate equal to K into concentration of reactant to the power order, and in this case the order is 0. So can I write it this? This is the rate expression for zero order reaction of a simple reaction, reactant to product. So minus dr dt is equal to K into R to the power 0. We can write it simple one, very simple. Okay. So can I write minus dr dt equal to K, because R to the power 0. Hope you are doing with me also. Please do it with me also. Minus dr dt equal to K, because R to the power 0 is nothing but 1. Okay, or we can write minus dr equal to K dt, Okay, so just as I told, simple mathematics, a simple simplification of a term. The concept, the physical concept of order is already done over here. In this first expression only the physical concept of order is done. Then just we are going to do little bit of mathematics, derivation, to get the value of K, simply to get the value of K. Okay, so minus dr is equal to K dt. Now write integrating both sides, integrating both sides. If we integrate both sides, we are going to get integration minus dr equal to integration of K dt. How are you going to get this? Integration of minus dr equal to integration of K dt. So if we integrate this, some integral formula, especially for the non-students, I am telling that you must be knowing it also, because in physics you are doing a lot. In chemistry also you have to do. Okay, so little bit the basic formulas of the integration and differentiation, all of you should know. This is just a basic one. The formula, the basic one which we are using is integration of dx is equal to x. Integration of dx equal to what? Is equal to x. Simply we are using that particular formula. But one thing you must know is that whenever we are doing the integration without any limit, integration means what? Integration means extension. Extension. It's just extension from one limit to other limit. But whenever we are doing it without limit, here we are doing it without limit, there is no limit, then there must be a term called integration constant should come. Integration constant should come. Since here we are doing the integration without limit, so the value of integration constant should be there. So if we integrate minus dr, so obviously dx equal to x. So it will be nothing but minus concentration r. Okay, should be equal to, now k is constant, that will come out of the integration. So it is actually k integration dt. K integration dt. Integration dt means it's nothing but t. So it's k into t. But as I told, since we are doing the integration without limit, without any limit, there will be some integration constant, and let me write it as I. Okay, where I is integration constant. I is what? I is integration constant. Integration constant. Okay, that's I. Fine. Now we are going to get the value of I first, and then we are going to derive this equation. Okay, derive the value of k. How to get the value of I? We'll put some condition now. We'll put some condition. Please understand the physical meaning of the condition. But mathematically nothing is there. Just understand the physical meaning of the condition. At t equal to 0. What is the meaning of this? At t is equal to 0 means time equal to 0. Means when the reaction just about to start. Just about to start. The reaction did not start. It's about to start, just about to start. Time t is equal to 0. At that particular time there is no product, only reactant is there. Okay, and let the concentration of the reactant at that particular time is indicated as concentration of the reactant is 0. We say it this. Concentration of reactant is indicated by R0. R0 is what then? R0 is, can we say it as initial concentration of the reactant? R0 is nothing but initial concentration of the reactant. We are just going to put this condition, put this condition in the above equation. Just write putting this condition. Hope you are writing putting this condition in the above equation. Putting this condition in the above equation, we get, putting this condition in the above equation, we get. So what we are going to do, we are going to put t is equal to 0 and r is equal to r0. So what we are going to get, minus, in place of r we are going to write r0 equal to k into, in place of t we are going to write 0. So k into 0 means 0. So that is equal to I. By putting this condition, our intention was what? Our intention was to get the integration constant, and we got the value of integration constant. What is this? This is nothing but minus R0. Before that, you can give this equation a number. Suppose equation number A. Just give some number to this equation number A. Okay. So now you write, putting the value of I in equation A. Putting the value of I in equation A, we get, putting the value of I in equation A. You might think that sir is doing very easily. Okay, it's very easy only. But initially, if you think it easy, when you are doing with me, you will find it easy. But when you will try to do by yourself, you will get stuck. That's very natural because you are doing it for the first time. If somebody tells me to do it at 3 o'clock also at night, I can do it. So it's not an issue for me. But for you, it's an issue now because you are learning it. So just little bit, few times of practice is needed. So please practice it for few times, these derivations. Whatever derivations you are doing in physics as well as chemistry, it needs a few times of practice. Okay. So minus R0 equal to I. Fine. Now we are putting this value in equation A. So what we are going to get? Minus R equal to KT minus R0. Just in place of our I, we are writing minus R0. Okay. So we are going to get this equation. give this equation as some certain name. The name is B. Suppose this equation is B. Our intention is to find out the value of K. Our intention is to find out the value of K, or the expression for K. So can I write KT is equal to, this will come this side, means equal to concentration, just to rearranging it, concentration R0 minus concentration R. Can I write it? Concentration R0 minus concentration R. Okay. Therefore, K is equal to what? Our expression, once again I am saying our intention was to find out the value of, or find out the expression of K. So K is equal to concentration of R0 minus concentration of R divided by T. Okay. Is that the expression for K for the zero order reaction? For the zero order reaction, the value of K, the rate constant, is nothing but concentration R0 minus concentration R divided by K. Yes? Okay, sorry, divided by T. That's the expression. Now, the graphical representation. Why did I tell you to mark these equations 1 and 2? Now, we are going to know the same thing, that is the first zero order reaction graphically. Now, again, whenever we are doing it graphically, please understand it again, the same thing. This equation, equation B, that we got in the derivation, from where we will draw the graph. Simply just multiply it. Okay, write it down. Multiplying equation B by -1, multiplying equation B by -1, multiplying equation B by -1. What we are going to get? Multiplying equation B by -1, we are going to get R equal to minus KT plus R0. Are you going to get this? If we just multiply both the sides by -1, this is becoming plus, this is minus, this is plus. So that is what I wrote over there. Minus R equal to R equal to minus KT plus R0. Now we are going to plot it graphically. You know, this is Y, this T is X, so minus K is M, okay, and this is C. I taught you last time also. Again I am saying you must understand this. So this is what, if I plot concentration of R versus T, concentration of R in the y-axis and a T in the x-axis, no need of remembering, again and again I am saying. So we are going to get a straight line, because this is matching with a straight line equation. Y is equal to mx plus c. What is m now? What is m? M is the slope and c is the intercept. We know this. M is the slope and c is the intercept. This value of m is how much? The value of m is minus k. That means the slope is negative. The slope is negative. What do you understand? What do we understand by negative slope? That the value of, so if I plot, so the graphical representation is very simple. So if we plot concentration R versus time T in the x-axis and R in the y-axis, we are going to get a straight line whose slope is negative. Whose slope is negative. Negative slope means the value of y will decrease with the value of x. In this case, the value of concentration R will decrease with value of concentration T, and in a straight line uniformly. So we are going to get a slope like this. We are going to get a straight line like this. Okay. Whose slope? What is slope? Again I am coming to that. I told you that in the previous chapter. Again, what is slope? Slope means nothing but what's nothing but tan theta, and tan theta is what? Tan theta is perpendicular by base. So if you measure the perpendicular and if you measure the base, you are going to get the slope. And this slope is going to give us the value of what? This slope is going to give us the value of minus k. Slope is how much? Slope is minus k. So graphically also we can find out the value of k. The value of k can be found out or can be calculated graphically also. If we plot the graph, we can get the value of k graphically by measuring the slope. Okay. And what is intercept? If we just extrapolate it, you know this, if we just extrapolate it, wherever it will cut the y-axis, that is C. That is C. What is this actually? See, at t is equal to 0. At t is equal to 0, whatever is the concentration of R, whatever is the concentration of the reactant, is the intercept, and that is nothing but R0. R0 is what? R0 is initial concentration of the reactant. So this is the graphical representation of what? This is the graphical representation of the zero order reaction. One more term we must know about this zero order reaction, that is half-life period. So first we had done with the expression of K, then the graphical representation, and the next one we are going to do is the half-life period. Half-life period of the zero order reaction. Half-life period of the zero order reaction. Half-life period. Half-life period is expressed as, first of all, it is expressed as T half, or in some book you can find it as T 0.5 also, the same thing, T half or T 0.5, that is half-life of a particular reaction or a particular process. Now what is half-life? What is half-life? Half-life is, suppose we started with 100 gram of reactant. 100 gram of the reactant. As the time goes, the amount of the reactant will decrease, right? From 100 it will become 95, say 90, and it will decrease, so on. One time will come when it will become half of its initial value. If we start with 100, one time will come when it will become 50. That time required to make the concentration of the reactant half of its initial concentration is called half-life period. Physically, please understand it. Then automatically, whatever I am saying, we are going to write it in mathematically. Okay? What is half-life period? It's the time required to make the concentration of the reactant half of its initial concentration. Whatever is the initial concentration. If the initial concentration is 500, one time will come when it will become 250. That time required is called the half-life period, and it is denoted as T half. Hope all of you understood what is half-life period. Now whatever I said, the same thing I am going to write it mathematically. Please understand this. At T is equal to T half. At T is equal to T half means when the time is a half-life period. The concentration of the reactant will be equal to concentration of R0, that is initial concentration of the reactant, divided by 2. Is that the definition of half-life period? That it's nothing but the time required when the concentration of the reactant becomes half of its initial concentration. Okay? Whatever I said, I just wrote that in mathematically. That at T is equal to T half, that means when it is the time required for the reaction to make its initial concentration, make the concentration of the reactant half of its initial concentration. Okay, so same thing I just expressed it over here. Okay, now this particular condition we are going to plot in the equation of K. This particular condition, so you write, by definition, half-life period can be mathematically written as, by definition, the half-life period can be mathematically written as this one, at T is equal to T half, concentration of R is equal to concentration of R0 by 2. Okay, fine. Now we know K is equal to what? We know K is equal to concentration of R0, just now we had derived it, minus concentration R divided by T. We know this. Now we are just going to put this equation, put this condition. So K is equal to, you can write K is equal to concentration R0. Now what is concentration R? Concentration R is nothing but R0 by 2. Concentration R is nothing but R0 by 2, and at this condition, so that is concentration R0 by 2 divided by T is nothing but T half. T is nothing but T half, because we want to get the expression for T half. So in place of T we are going to write T half. So if we just simplify it, what we are going to get? K is equal to, this is what? 2 is the LCM, 2R0 minus R0, so that is R0 by 2 divided by T half. Okay, therefore that is equal to, can I write it, concentration R0 by 2 T half, can I write it? Okay, so T half is equal to how much? So T half is equal to how much? T half equal to concentration of R0 divided by 2K. Can I write it? Is that the expression for the half-life period of the reaction? Is that the expression for the half-life period of the reaction? Okay, so this is half-life period of the reaction for the zero order reaction of the zero order reaction, half-life period expression for zero order reaction. T half is equal to concentration R0 by 2K. Now can I write it? You know, K is constant for a particular reaction at a particular condition. That's the rate constant. So can I write T half if at a particular condition, can I write T half is directly proportional to concentration R0? Can I write it? Because this is constant. K is constant means 1 by 2K is also constant. So can I write T half is directly proportional to concentration R0? Okay. Hence in words, what can we say? That the half-life period of a zero order reaction, is directly proportional to the initial concentration of the reactant. The half-life period of a zero order reaction is directly proportional to the initial concentration of the reactant. Okay, initial concentration of the reactant. Now just write a numerical, you do it. Okay, hope you understood that. Now first write a numerical, then I will come in the discussion mode. Okay, write a numerical first. If a zero order reaction, just arbitrarily I am giving, just to understand that whether you understood the concept or not. If a zero order reaction is 20% completed, if a zero order reaction is 20% completed in 50 minutes, 20% completed in 50 minutes, 20% completed in 50 minutes, find out the time required, for its 70% completion, and also find out the half-life period of it, It will take hardly 5 minutes time, maximum 5 minutes. It should not take 5 minutes time. So proceed it and write down the answer in the chat box.